Let us look at recursive insert function for binary search tree. We can generate an entire binary search tree by inserting keys one by one. So we can call this function every time for inserting a key. As the function is recursive, so already I have written the function. I will trace the function and show you. Suppose from main function, I have a root pointer which is already null. The first key I will insert, I will call insert function by passing this root and key is 30. See, I am calling insert function for the first time by passing root which is null right now, and I am passing key as 30. So what happens, how this works, let us see. So right now root is null, right? So when I call insert function by passing root, so that root is p here and it is right now null. So root is null. So what is the first statement? If p is null, yes, p is null right now. So create a new node, set the key in data and set left and right child as null and return this t, that new node. So create a new node with the help of temporary pointer. Insert data 30, that is key. Make this left child and right child as null, then return t. So this node's address is returned from there. So that address I can take it in root. So root will be pointing on that node. So this is the first step. So when I am creating first node, root should point on that one. That is the reason I have assigned it with root. So root was null. Now root will be pointing on that one. This is the first step. Now let us insert few more keys. I will say insert. I will pass root now. Root is pointing there on that node. Root and the value is 20. I don't have to assign it to anything now. Already I have root pointing on that root node, that is first node. Let us see. P is upon root. Yes, P is upon root. Then P is null. No. So it will not enter into this block. Then key that I have sent 20. Is it less than P's data? Less than P's data 30. Yes, it is less. So go on which side? Insert upon left child. So it will call itself again. So again the insert function is called by passing P's left child. So what is P's left child now? P's left child is null, right? This left child is null. So this is null. So it will call itself. Right now P is null. So create a new node. Okay, create a new node with the help of T and insert this key, set this as null. This is what the common work done every time. When the pointer is null, create a node, set the data and initialize pointers to null. That's what the common steps are. And return this. So this T is return. New node's address is returned. So when it returns, it goes back to the previous call. And in previous call where P was here. First call P was here, right? So in that call, P's left was null. Now you can see that P caps left child or P's left child is assigned with the result returned by this insert function. So it will return the address of this node. So it will be assigned here and it will be pointing here. So from this call also it will return. So it will return the same address P from this node. So it will go back to the previous call. So there was no previous call. This was the first call. So this is the only important statement that I have to explain you. That is, a new node is created and assigned as a left child. So when it returns, it will return the new node's address that will be assigned to the left child. I will insert one more key and show you. Insert 25 and the root is passed. Insert 25, root is passed. So this P becomes root. So P will be pointing on this one. Is the P null? P is not null. It will check key, the value that I am inserting, 25. Is it less than P's data? Less? Yes, less. So call insert again on left child. So a new fresh call will be made upon this left node. So P will be pointing here. Again P is not null. So again call. P is null? No, it's not null. Then here key, is it less than P data? 25, is it less than 20? No. Key is greater than P data? 25. Is it greater than 20? Yes. So call itself again upon right child. So P will call itself again upon right child. So right child was null, so right now P is null. So in this call, P is null, so a new node will be created, initialized, and its address is returned. A new node is created, initialized with the key that we have given. These are made as null. Its address is returned. So from where it has came from this node. So P will go back to that node in the previous call. So what was the statement? It's not completed right now. This assignment has to be done. So P's right child will be assigned with that return address. So P's right child will point on this one. So this call has finished, so it went back and assigned this link. Now this call also finishes, so return P. So simply it goes back to the previous call, right? From here it has came to the left side, so it will try to assign the same address again here, and it will go to the previous node. So this address will be, see, like this address is assigned here, so this node's address will also be assigned here. So it's the same address only, it makes no difference. So reassignment of the same address will be done. Then from this call also it finishes, so that's the end because that was the first call. So this is how the keys will be inserted. I can go on writing insert function for inserting various keys in binary search tree. So that's all. This is a recursive function. So I'll show you the demo of this function. I will include it in the program and show you a demo of this function.